talk about inverse trig functions, but make sure you have finished up your practice on right triangle trig before then. So moving on to station 2, if you're fast forwarding, we're live right now, so that's super exciting. So now I'm looking at inverse trig. I'm going to do, again, these two boxes up top. This is your practice. So let's get started. So to find a missing angle in a right triangle, notice how last time on the last practice we only were using angles to find missing side lengths. I can also use my trig ratios to find my missing angle in the triangle. So to find a missing angle in a right triangle, we must use inverse trigonometry. So this example right here is exactly that. So the sine of an angle equals a value. So throwing it back to the front side, if you want to follow along, we saw that the sine of angle A was equal to 8 over 17. So the sine of angle A is equal to 8 over 17. 8 over 17 would be my value. We can redo that as sine inverse of that value equals an angle. So the inverse sine of the value is equal to an angle. So looking down here, I have the sine of 30 degrees equals 0.5. So the sine of an angle of 30 degrees equals 0.5. The inverse sine of an angle, the inverse sine of the value, I'm going to write that in because I just messed that up as I was talking. So sine of an angle equals 0.5. Inverse sine is going to be the value of 0.5 is going to equal an angle. So we can tell what that angle is going to be based on this example, but let me look and see. I'm going to show you in a calculator how we can figure out exactly what that angle is going to be. Again, we kind of know what it should be based on the fact that we just flipped those values. But first we're going to do something in our calculator together. So I want everyone with me right now as you're watching this video, pull out your calculator. I want you to hit dock, go to number 7, settings and status, go to document settings, number 2. Where it says angle in the second spot, you see how it says degree here? Some of your calculators might say radian. I want you to go down from radian, click degree, and then hit enter. And it's going to ask if you want this applied to your settings. Just say okay, because that's what we do want. Radians are something we're going to cover after Christmas break, but we want our angles to be in terms of degrees. So make sure we go to our angles and hit degrees. Now, I realize now that on the first part of this video, we haven't talked about how to get to trig identities yet. So hopefully you will have asked one of us about how to do that. So we are going to go to the trig button. And so we see at the top, we have sine, cosine, tangent. Those last three, again, are something we're going to do after Christmas break. But we're going to go down to the inverse. So that little -1 means an inverse. We've seen that before with function notation. So I'm going to type this into my calculator and see what I get. So I'm going to hit the middle button on that sine inverse. I'm going to type in 0.5. And I get 30 degrees, which is an angle, out at the end. So once again, I went to the trig button, which is right here underneath the control button, went to sine inverse, typed in my 0.5, and got 30, which is exactly the mirror of what we had on this side. So sine of 30 degrees equals 0.5, inverse sine of 0.5 equals 30 degrees. If I typed it in my calculator this way, I hit trig, went to sine, typed in 30, I'd get 0.5. So we verified that both of those are correct. So let's see how this looks in practice. So let's get started. I have this missing angle right here, question mark. I'm going to call that angle I, which is what they call it up top. So angle I, I'm going to rename that theta because that's what we've seen before. So here I'm trying to find what relationship this side and this side had to angle theta. So if I'm looking here, I see that this side, Ki, is across from my 90-degree angle. This is going to be my hypotenuse. Also because it's the slanty side, if we want to be less technical. This is my hypotenuse. I now want to find out what line KP, what relationship that has to my theta. So if I'm looking this side over here is opposite or across from my theta, I'm going to label that as opposite. What I do when I'm trying to figure out which trig ratio I want to use, I always write out SOHCAHTOA so that I can look and see what I have. So here, I have the opposite in the hypotenuse, so we are going to end up using sine, because then I don't have to use the Pythagorean theorem to find my missing side. So I want to use sine, because I have my opposite and my hypotenuse. So sine of theta is going to equal opposite over hypotenuse. Sine of theta equals, let's fill in those values, opposite, I know that that side is 8, my hypotenuse is 10. So that's exactly like what we would have solved with on the first side, but I know that I want to find out what is the measure of theta. So I'm going to take sine inverse of my value, which is exactly what we did up here. My value was 8 over 10. Inverse sine of my value is going to equal my angle, which is exactly what I have up here too. So then I can go to my calculator, hit the trig button, go down to inverse sine. I know that my value is 8 over 10. Hit enter. I know that theta is equal to 53.13 degrees. This is one of those things that I think takes a little bit of practice, so if this was a little bit confusing, don't worry. It's helpful to work through these bottom problems on our own. But with that, it is time for practice. Make sure if you have any questions, you call either me or Miss Avera over, and good luck with the rest of your practice.